Hello everyone and welcome to my channel. In today's lab, we are going to be creating and managing security policy rules. Palo Alto Firewall, this is part of a series, an ongoing series, and today our goal is to configure some policies to test access from our DMV, DMZ zone to our other zones, to our internal user zone, and to our out to the internet. We're going to view traffic logs, examine policy rule count, reset rule hit counts, customize policy tables, enable intrazone and interzone logging, and create security policy rule to the internet. So let's begin. And again, this is part of a series, an ongoing series. So hopefully you guys are able to watch the previous videos and follow along as we go. So let's begin. So first things first, I have this firewall is pretty much, for the most part, just straight out of the box. So there are roughly no configure, very little configurations. Again, instead of reconfiguring the entire firewall, each and every video, um, I save my running config from the previous video, and then um, I save it, I export it. So I save my previous running config, export it to my local machine, and then I import it back in, and then load it and commit it. So that way I'm not always starting off each video from the very beginning. So first thing we want to do in this video is we want to create our first policy, which is exciting. Policies are going to allow us, allow the firewall to pass traffic from one zone to another. So this is how, um, this is the sole purpose of firewalls, essentially. So this first policy is going to be user zone to, I'll just do users to Extranet or DMZ, and a description. Descriptions are good for auditing purposes. I like to add descriptions. I've worked in environments where it wasn't necessary and environments where, it was required. And personally, my personal preference is I prefer to add descriptions because as a firewall administrator, when I open up a policy that's that's pre-existing, if there's a description, um, it helps me understand, you know, why the policy was created, when it was modified, so forth and so on. So at a glance, I can get a better understanding of what the policy is doing, especially in the name as well. If you name a policy, um, if you have a good naming convention procedure in place, just reading the name of a policy will give you an idea about what it's doing. But in the description as well, in production environment, there are ticket numbers, change requests that come in, and a good best practice is in the description to kind of add the ticket number, add your admin username, and explain why the policy was created. So this policy is going to be allows host in users net zone to access servers in DMZ. So, okay. So the source is obviously going to be our users net. Our destination is going to be as we defined it, the extranet or the DMZ. Our application is going to be any, so we're not going to create, this is not going to be a specific app ID rule. This is just allowing traffic from one zone to the next. Okay. So service, application default, URL, any, action, allow. Log at the end of session. Click OK. So we're going to commit that. I like to close this and go do other things, as I've mentioned in a previous video, and then you can select the task manager and check your progress. But so once that is complete, next thing we want to do is modify um, security policy table columns. So one way to do that is we can click here, this little drop down arrow, go to columns. I love this feature in this firewall too. This is part of why I fell in love with Palo Alto firewalls. Um, no knock against Cisco. I absolutely love Cisco products. Cisco is was my foundation, my background. But once I started getting familiar with Palo Alto firewalls, I just fell in love with the simplicity and how intuitive the interface is, and all the little what I call fun features um, are with these firewalls. I just think it's incredible, and something as simple as this just is a perfect example um, of what made me fall in love with these firewalls. So here we're going to remove some of these columns. If you notice, the output is kind of verbose. There's a lot of columns here that we may or may not need. It just depends on what you're trying to accomplish. I'm going to close this menu. You can close this sidebar menu, which is this little arrow here. You can close that out. You can go here, click this down arrow, go to columns, and we're going to remove type. So we're going to remove this column, type. We're going to remove source device, destination device, and the options column. Okay. So if you guys just notice, I adjusted the columns, and what it does is it fits the text to the columns. Okay. So type, we're going to remove that column, source device, destination device, and the options column. Okay. And that kind of cleans up our inner our policies page. So that way we can kind of focus more on the things that in the columns that are actually useful to us. You can actually drag and drop columns too. So there's an actions column here, and you can drag this over. As you can see, this should let me drop it in. Interesting enough, here we go. Okay, there we go. So you can rearrange the columns as well, and you can place them in an order that, you know, depending on what you're scanning for, uh, you know, when you're looking at the actually policy page, it'll help you kind of key in on the columns that are most important to you. So yeah, you can scoot this over, you can scoot it back, you know, reposition it however you choose. That's fitting for you know, your eyes, and when you're looking at this. When you're looking at this all day long um, for a living, little things like that just help you uh, do your job in a more efficient way. And I'm big on efficiency, so I think it's great. All right, so next we are going to from client A. So this is our internal client. You can see client A, right? And if I do IP A, you can see the internal IP address, 1.20. These are the addresses for the other interfaces, but 1.20, or we could do config. All right, and you'll see our IP address there. So I'm going to ping our DMZ server, which is located at 192.168.50.80. And because we created this policy, users to DMZ, we're now able to ping that address. Now, if that policy were not in place, we would not be able to ping our internal resource because next-gen firewalls and firewalls in general, especially zone-based firewalls, work. You have to define um, a zone that you're reaching out to. And in next-gen firewalls and zone-based firewalls, if there's not a policy that's defined, you won't be able to reach uh, that particular zone. So let's see. So we're going to go now to our browser. And we're going to type in the address of 50.80, 192. Okay, so it's working. So we've tested connectivity from user zone to the DMZ, which is great. And next, we're going to view, since we've reached out and connected to the DMZ server via via the web interface, and we're able to ping it, we should be able to view our rule hits. So our hit counter is here. You can see users to DMZ. This policy is going to be hit anytime we reach out to that destination. So you can see our hit count here, and so that's pretty self-explanatory. We could also, if we want, we could reset this rule counter here or here. We could reset all rules or just this selected rule because we have this rule selected. Notice it's highlighted in blue. So if we wanted to, we could just reset the hit count on this rule by going here, clicking the little down arrow, click reset. That's at 0. Watch this, we'll ping it again. Right? We'll refresh the page. And you'll see the hits are back because we're currently pinging that device. Refresh again. You'll see the hit count go up, so forth and so on. So there's two ways to reset the hit counter. We could go here, reset the hit count for all the rules, or just that selected rule. Pretty straightforward. So now we're going to jump over to our monitor tab. And as you can see here, you can see where we're pinging out, from the zone, from zone usernet to zone extranet source 154, which is the interface address of the firewall, right, to that destination. So what we're going to do here is we're going to again manipulate the columns, and we're going to remove the type column because in this scenario it's not useful. We're going to remove type, source dynamic address, dynamic address group, destination, and dynamic user. We can remove those, and you see it cleans up our log dashboard, our log UI. so that now again we can focus on the columns that matter to us. Next, we're going to test ping. So next what we want to do is we want to see if we can reach the internet. So 8.8.8.8 is Google's address. So essentially we're telling our internal host, ping Google, right? And let's see what response we get. Let's see if we get a response. Okay. And it appears we're not getting the response. Yep, so Control C. Yep, 100% packet loss. So we are not able to ping Google yet. So let's see in our logs if we see any filters for ping. So we do not see any filters for ping, right? We just reached out to Google trying to ping Google, and so therefore there should be logs, right? You guys are asking, hey, where are the logs? There aren't any, right? Part of the purpose of traffic logs is to log all traffic coming in and out of the firewall, unless there are scenarios where you don't want some traffic logged. There may be particular data that you don't want logged, or you may be have created a rule that blocks certain traffic, and as a way to um, one, not uh, for cost purposes, right? Because logging cost um, has associated costs, especially if you're deployed in a cloud environment. Um, it could be that, but there could be various reasons why you decide not to log certain traffic. But the reason why that traffic isn't being logged is because of that traffic is hitting um, that traffic is hitting our interzone default rule. So interzone and intrazone. Intrazone traffic is traffic that is within the same zone. So let's say I'm going user zone to user zone. That's what's defined as intrazone with an A, intrazone traffic. If it's same zone, it's intrazone. If it's different zones, it's interzone. So therein lies a difference. Intrazone is same zone to same zone, so it's trust to trust zone, right? And interzone would be users to DMZ zone or users to internet, right? So if you're going from one zone to another, that's different, interzone. Same zone, intrazone. So in order to log that traffic, because by default, that traffic is not logged by the firewall. So we're going to click the override button for the interzone default rule, actions. Okay, traffic is being blocked, but notice how log at the end of session is disabled. So once we click this, click OK, commit. All right. Once that commit is complete, we're going to ping the internet again. We still won't be able to reach the internet, but logging the firewall will begin to log that traffic. So give that a minute to complete successfully. Now we will ping the internet again. which again, remember guys, we're not going to be able to ping yet because there's no policy in place, right? But what we're doing is we're just verifying and validating that the firewall is actually logging that traffic. So we're going to click our refresh button. And as you can see, users to internet, that's the source interface. Destination is Google, denied. So now it's logging that traffic. Make sense? Okay. So next we want to, let's see if we can create a policy to actually ping the internet. So we're going to add, we're going to do users to internet, allows users net to users net traffic to reach the internet. Pretty straightforward. So again, our source zone obviously is going to be users net. Destination is going to be the internet. And we don't mind if, what applications or what traffic, um, what ports the traffic is traversing, right? So application, any URL, we're going to allow it. And of course, we're going to log the traffic at the end. Okay, commit that. Click commit. And once that is done, as always, we will test it. And let's see what happens. Now, the commit is not complete yet, but I'm just running ping anyways because I know once it commits, you'll start to see the ping keep alive once the commit has completed successfully. Okay, let's see. So it has completed. Still no ping. Interesting. Why do we think that is? We've created a policy. We've created a policy here that should allow access out. So why isn't it working? Let's go to the monitor logs. I know why it's not working, but I'm curious to see if you guys know. So we can see users to the internet, interface address 8.8. Oh, traffic is allowed. How about that? So notice it's changed. It went from denies. It went from denied previously. Where's our deny? Our deny was, I could filter on it, but previously where traffic was denied, now it's being allowed. But now the reason why it's not being allowed is because you cannot route private IP addresses, which this would be considered a private internal IP address, out to the internet. Private IPs are for internal use only. So you can only, you know, I can ping the DMZ zone because it's also using a private IP address, but I can't ping out to the internet from a private address. Think about it this way. Think about um, what's a good example? Uh, let's say you live at 123 ABC Street, right? And you want to send a package to Amazon.com. But Amazon requires you to use a PO box for some strange reason. So if you try to send, you know, purchase something from Amazon and you use your home address, Amazon says, no, we only accept PO boxes. So that would be a situation, an example of where you can't use your personal address to reach out to an external resource. So in that event, you'd have to use a PO box or forwarding address. So what we'd have to do is create a NAT policy, which we'll get to in another video. You'll notice here, NAT. Um, this NAT policy would be like your PO box. So you'd create a NAT policy that says, hey, anytime you see um, traffic, or request from 123 ABC Street, which is your home address, change that into PO Box 123 and then send it out. So it's a buffer between your internal, and it's a great security feature as well. It's an internal buffer so that your internal addresses aren't exposed to the internet. So, but we'll circle back to that um, in another video. So now what we're going to do is we're going to create some block rules. And these block rules are going to block traffic to bad addresses. So they're going to um, prevent our internal users from the DMZ or Extranet just call it the DMZ for the sake of consistency. They're going to prevent users. Let's say I wanted to prevent John in accounting from reaching out to Facebook while he's working. So I could create a policy that says allow John to reach out to the internet, but block John from going to these particular sites. So this is going to blocks traffic from users and extranet to known bad IP addresses. Okay. So we're going to add, and remember guys, you can add multiple zones um, within a policy, right? So it doesn't just have to be one-to-one zone. It doesn't have to be users just to DMZ or DMZ to users. You know, you'll notice in this policy we're going to add both users and extranet, right, out to the internet, right, and the destination address, which Palo has pre-loaded. Um, and again, in another video, maybe we'll get into EDLs, but these are lists that Palo Alto itself has a database of um, IP addresses that are known bad IP addresses. If that makes sense. So it's imagine um, let's say you're trying to go to www.badsite.com. If you enter that into your browser might say, hey, depending on what security features you have on your browser, let's say you're using Chrome or Microsoft Edge or whatever your browser of choice is, Firefox. Firefox might say, hey, this is a known, hacker.com. They, your browser might give you a warning, say, hey, this this website, this IP address is known to be a malicious website that could damage your computer. So don't go to it essentially. So Palo Alto has a database of known bad IP addresses that um, that you can, you know, that are updated on a regular basis that you can add to a rule that will help filter your traffic and block users from going to those sites. So I don't want to belabor the point, but hopefully that makes sense to you guys. See, high risk IPs, known malicious IPs, right? So now what we just did is we said, okay, the rule is block known addresses, right? Blocks traffic from users in extranet zones to these destinations, right? And the application is going to be any, right? So we're going to click OK there. And of course, the setting is going to be to deny traffic. And maybe later on I'll do a video of each one of these separate actions taken on a policy. You know, deny obviously blocks, allows, but drop, reset client, reset server, and reset both have separate purposes, which is kind of cool. So, um, so that is a deny policy, right? Because we're blocking traffic to those sites. And now we're going to create another policy in the reverse. So when you create a policy, let's take a step back. When you create a policy, whatever you create as a source is going to initiate the traffic. So whatever you create as the source, whatever you put in the source column, that's going to be the initiator. So consider the initiator as if I have a friend named John or Robbie, and I'm calling Robbie. I'm initiating the phone call, right? Because I'm calling Robbie. But if Robbie calls me, then Robbie's the initiator. Okay? So just think about it that way, that when you're creating a policy, you're creating it from the perspective of who's initiating the traffic, from where to, from to. Like when you send a letter from John to Sarah, right? John's the initiator, Sarah's the recipient, right? If Sarah is sending John a letter, Sarah's the recipient, Sarah is the initiator, John's the recipient. From Sarah to John, from John to Sarah, from Sarah to John. So when you're creating a policy, you want to be able to visualize where traffic is being initiated from. So in this next policy, and what I'm going to do to make this a little simpler, now I'll just create it brand new. I could have cloned this rule. I could have cloned it and then just rearranged it, but which is something we can get into too. Cloning rules. Cloning rules helps create rules quicker. It's just more efficient. But so we're going to do block from known bad addresses. So that's saying, so the first rule was we're blocking us from reaching out to bad addresses, and now we're creating a rule to block bad addresses to reach us. So blocks traffic from known bad IP addresses to users, to us. Okay. So that traffic would be initiated from, where you guys think? You think it'd be coming from the extranet or usernet? No. It's going to come from the internet. And these are the source addresses. So this essentially, we're just creating the same rule that we created, but the previous rule. We're just recreating it in reverse. So we're saying we can't reach out to them and they can't reach into us. Okay. Users net, extranet. All applications are going to apply. Doesn't matter what app, doesn't matter what service. We're going to block this rule, right? Obviously, we're going to log it and we're going to click OK. Now, we've already created a policy. Um, and let's do this. Let's take this rule and let's put it at the top, right? Let's move this rule. Here's a move button here. Move to top. There we go. And you can actually grab and drag rules as well. So we're going to take this rule and we're going to drag it up. So it's just below our first rule. Makes sense? So you can grab rules because here's how the firewall is processing rules. When traffic comes into the firewall, the first rule it looks at is rule number 1. Then it goes to rule number 2. So it processes rule in sequential order. And when all else fails, if there's no traffic that matches any of the policies, it just drops the rule. It doesn't allow the traffic unless it's intrazone traffic, right? Which is a default rule, right? So if it's same zone, it'll allow it, but there's an implicit deny at the end, all right? So again, like columns, you can shift columns back and forth. You can also move rules in the rule order. So next, what we want to do is we want to circle back to the rule, this internet rule, so that we can reach out to the internet, right? Because we just created rules that block internet traffic from initiating traffic internally and block us from reaching out. But now we also need to add a rule that will allow us to reach out to the internet because we can reach the DMZ, but we cannot reach the internet yet. So this is where natting comes in, where the forwarding address comes in. So let me take a step back and verify that I have created a users to internet rule, which is an allow rule. Yep. And we're also going to clone this rule. So now you guys get to see cloning. We're going to just select the rule so this is highlighted. Click the clone button, right? It's going to ask in the rule order you want it. It's going to give you an option. It's going to say you selected this rule, right? Where do you want to create it? Rule order. So do you want to move it up? Do you want to move it down? Do you want to create it after the rule that you're cloning? So it's asking us, do you want us to put your new rule after the rule that you're cloning, right? Right at the bottom. So this is super cool. This is just so fun. Just how you can manipulate the rules and um, place them, pretty much wherever you want. So yeah, we're going to create this rule beneath our users to internet rule. Notice it'll add a -1 to the rule, right? So that we know, oh, this is a clone rule because it has a -1. So we're going to open up this rule. And we're going to rename it. Instead of users to internet, it's going to be extranet to internet. Allow extranet user. Well, no, let's just do extranet. I call this area the extranet. I call the DMZ, so I hope it doesn't confuse you guys. But let's go source. So we're going to delete this source because it's no longer users to the internet. It's now extranet to the internet, right? All the same parameters apply. Click OK. Now we're going to click OK. We're going to commit this. And once we commit this, we're going to test connectivity. Jump over to our monitor logs. And a monitor log is essentially when you jump over to your logs, your traffic logs, your monitor tab, traffic logs. Again, guys, remember this is where you can test and validate that a policy that you just created, connectivity, is established, right? This is where all this happens. So hopefully that makes sense because it, you know, sometimes it can be confusing, but you can see extranet to internet, usersnet to extranet, that's allowed. Extranet to internet is denied, right? You see that there. Um, users to internet, it's being allowed, right? But there's no real connectivity, and we can test it. We could do um, again. So this is from our internal host, the 192.168.1.20 address, right? Let's see if I SSH admin, this might work. 168.50.80. Let's see if I can SSH over to our I don't think I remember the password. Let's try it. Okay, I forgot the password, but if we could, um, let's see. Okay, we can. Here we go. So from extranet, so I have an RDP session set up here. Um, so now I'm logged into this is our web server, right? It's our web server. And let's see if I can ping Google from the web server. And we can. And again, the only reason we can't ping out is because we don't have, again, you can't route traffic from a public IP from a private IP to a public IP. So 192.168, that's our private address. It's like your home address. In order to reach the internet, you have to use, for the sake of analogy, a PO box address. You can't just use your personal address. So I'm going to wrap this video up, guys. Thank you for your time. Hopefully it was helpful for someone. Um, and in the next video, we'll get into more connectivity, and I'll create a NAT rule that will show you guys how to uh, reach out to the internet using that quote unquote PO box address, that forwarding address. Thank you for your time, and have a great day.